Okay, hello everyone. Let us continue the second part of the course. Okay, because this term is a constant, then okay, equation 1 is equal to minus expectation minus 1 over 2 z minus mu transpose times RZZ inverse times z minus mu, and this term can be moved out of the expectation. Okay, and it becomes the plus. Okay, like this. Plus natural log the square root of 2 pi to the power of nr times the determinant of RZZ to the power of 1 over 2. Okay, like this. Okay. Moving. Okay. Moving the constant minus 1 over 2 out of the expectation. Okay, out of this. Okay, out of the expectation, we get equation 2 is equal to 1 over 2 here. Okay, and times the expectation. Okay, this. Okay, and this minus 1 over 2 disappears. Okay, 1 over 2 times expectation z minus mu transpose times RZZ inverse times z minus mu plus natural log the square root of 2 pi to the power of nr times the determinant of RZZ to the power of 1 over 2. Okay. According to equation 2.17. Okay, let us see equation 2.17. Okay, 2.17. Okay, this equation. Okay, let us copy it and paste to Word. Okay, Z. Okay, not italic. Z is defined as Z1 to ZNR transpose. Okay, where n R is the number of received antennas, and the superscript T denotes the transpose. Okay. Oh, sorry. This should be small w. Okay. Let mu is equal to the bracket mu 1 to mu n r transpose. Okay, like this, but this should be boldface. Oh, sorry, boldface and italic. Okay, let mu vector mu is equal to mu1 to mu nr transpose. Then then we focus on this term. Okay, z minus mu transpose times RZZ inverse times z minus mu is equal to parenthesis and z1 to znr transpose, like this, and minus mu1 to mu nr transpose and transpose, and times RZZ inverse. Like, I need to change this minus term to this, and move RZZ inverse down, like this, and times this term, times z1 to znr transpose minus mu1 to mu nr transpose. This is equal to this. And then it is equal to bracket z1 minus mu1 to znr minus mu nr, like this, and times the RZZ inverse, and times a column vector. Column vector, let us see this. Column vector, we need 3 elements. Here. So the first element is equal to z1 minus mu1. And the second element is dots. Let's see where is the dots. Here. And the last element is znr minus mu nr. And let me align this equation to the equality. I need to Okay, another equality here, and I make change it to a white one. Okay, perfect. So this is called the equation 6. Oops, I cannot do this here. Okay, I cannot do this. So equation 6. Oops. Okay, it is not perfect. Okay, so let me add a block. Okay, let me block and 6 like this. Okay, and I change this to the Cambria math. Okay, Cambria math. This. And no line here. Okay, and place it to right. Okay, okay, here. Okay, good. Okay, next let okay, that RZZ. Wait a moment. We need a equation here, and a subscript here, and a bracket here, and I copied RZZ inverse here. Okay, and here is I comma J and italic. Okay, that RZZ inverse IJ denote the element on the ith row and jth column. Okay, j column of RZZ inverse. Then okay, let us continue. Okay, then equation 6 is equal to, okay, this is the same. Okay, so I copied here, and RZZ inverse becomes a matrix. Okay, I need a big matrix here. Oh, sorry, I need a bracket first. Okay, and I need a big matrix. I need 1 2 3 1, yes, 3 times 3 matrix. And the first element is RZZ inverse 1 1, and this is the dots. Okay, and this is RZ, oh sorry, RZZ1 NR, or RZZ inverse 1 NR. Okay, like this. And this is the vertical dots. Oh, okay, vertical dots, and this is the diagonal dots. and this is the vertical dots again. And this is the RZZ inverse NR1. And this is the C dots. Okay. And finally, the last element is RZZ inverse NR. Okay. Okay, like this. And the next vector is the same. Okay, like this. And this is equal to, okay, we multiply this vector and this matrix first. So after the multiplication, we will get this vector. Okay, we will get summation. Okay, I is equal to 1 to NR. And this is okay, Zi minus mu I. Okay, Zi minus mu I, and this is should be this term. Okay, RZZ inverse I1. Okay, and dots, and okay, let me copy this. Okay, it should be italic, and this should be italic again. Okay, italic. Okay, so the last element should be I is equal to NR. Oh, sorry, this should be italic, and this should be italic. I is equal to 1 to NR Zi minus mu I times RZZ inverse I, and this should be NR. Okay, here. Okay, like this. And the final vector remains the same. Okay. So then we multiply these two vectors again together, and we will get this equation. Okay, please pay attention. It may be somewhat difficult here. It is equal to J is equal to 1 to NR. Okay, and this. Okay. I is equal to 1 to NR Zi minus mu I RZZ inverse IJ. Okay. And finally, this term should be okay, Zj minus mu J. Okay, do you understand this? Okay, I multiply this term and this term and so on. Finally, plus this term times this term. Okay, so we will have Zj minus mu J here. And another summation appears here. So this is equal to J is equal to 1 to NR. Okay. So this should be italic. And this J should be italic. And this J should be italic. and this J should be italic. Okay. Okay, good. So let me align at the equality sign. Okay, like this. So next step is more simple. Okay, this is equal to this equation. Okay, and I interchange I and J. Okay, and it does not impact the results here. So this J is italic, and this I is also italic. Okay, like this. Okay, and this term remains the same. So finally, let us write it as this. Okay, summation I J. Okay, and be italic, and this term, I copy this term to here, so this is remains the same. Okay, and I align these equations at the equality sign. Okay, like this. Okay, very good. Okay, so finally, this is equation 7. Okay, like this. No, I can't do this equation. Okay, so let me do this again. I copy this to this page. Okay. Okay, so I need to copy this to this. Okay, I move to here. Okay, so this is equation 7. Okay, good, perfect. Okay, on the other hand, I need to move it to, okay, here. Okay, on the other hand, okay, let us consider another term. Okay, this term, the natural log term. Okay, this term. Okay, so this is equal to, okay, natural log. Okay, the same. And let me remove this square root. Okay, to here, to the nr/2 power. And I copy 2 pi to here. Okay, like this. Okay, then next, okay, let me delete the over 2 term. Okay, and I delete this term, or 1/2, and I delete the superscript, and I make this, okay, 1/2. Okay, good, like this. So I move the power 1/2 out of the bracket, and according to a property of the natural log, we can know that we can move 1/2 in front of the natural log. Okay, so let me write this 1/2 and the natural log. Okay, and natural log this term. Okay, and let me delete it. Okay, like this. Okay, it is 25 minutes. Let us take a break.